Good afternoon, everybody. Thank you for joining us today at a Wednesday at the Watering Hole session, and we decided to focus this week on the question of how does nature treat wastewater? And we thought that might be partly of interest because wastewater has been in the news, maybe a little bit more than normal, and we watch for that kind of thing. Because of the coronavirus, it does show up in wastewater and has been detected in the effluents from different municipalities. And there's some evidence that it might be useful to be monitoring wastewater systems for the presence of the virus, of coronavirus, as both an early warning system and as a way to potentially detect like a larger outbreak than is tested otherwise. There's been some evidence that some sites that have had high levels of, or some communities that have had moderate levels of positive tests have a much higher virus load in the wastewater than would be anticipated. And so there's some question about, how we might be able to use wastewater to even detect like a wider spread than is otherwise being picked up. There is an understandable concern about the recycled water and wastewater treatment plants that we currently have, existing. Like, are they able to remove coronavirus from water and from wastewater? And generally speaking, the good news is that yes, they do have that capability, and the reason is that wastewater treatment systems are already optimized for treatment of things like viruses and bacteria and vectors. Similarly, recycled water, which is effluent that's treated and then is used for irrigation and for other uses, the process to be able to produce that recycled water is so robust that it's unlikely that much of that virus, if any, is passing through. And so that work is going to be ongoing, but there's been a lot of concern, obviously, in communicating the safety of the water infrastructure that we currently have for us to be able to handle that. Today's webinar is a little bit of a trick question of how does nature treat wastewater? We wanted to challenge that question because in nature and in natural systems, there is actually no waste. And that's part of the key of this understanding, is that in nature, all waste is basically food for something or someone else, right? When we have a plant that dies, it's digested and cycled into the next living creatures. And there are cycles that exist like that just go, on and on throughout the various different ecosystems. And so in nature, there is no waste, and there is not wastewater either. Humans, however, this is of our devising, was creating, wastewater from carelessness, really, and a misunderstanding about that natural cycle and the power of harnessing those natural cycles. And so our domestic and our residential use of water creates wastewater. Our industrial manufacturing and production of goods, that produces wastewater. Food production makes wastewater. Oil and gas extraction, that produces wastewater. So there's lots of different types of wastewater out there, and most of the time, those are more of a linear type of relationship where we use water, we pollute it or put into it whatever we want to get rid of, and then we send it on downstream and it wreaks havoc. And wastewater treatment itself was devised to be able to handle that problem, right? That straight line problem. And so there have been lots of evolutions of creating systems, wastewater systems that treat that water and that treat it well. I mean, it's possible to treat that water well. And there's a variety of treatment systems available. Some of those wastewater treatment systems are basically, using biology too. Almost all of them, in fact, are. They are using a microbiological approach where they're cultivating and growing bacteria that are, really good at removing the organic waste and treating that water with I don't want to say it's not a monocrop, but it's a set of wastewater type bacteria and microorganisms that are very good, and we've figured out how to optimize them to remove contaminants from wastewater. And those systems exist at all kinds of different scales. There's also this common, I hear it, this common misconception that, like, quote unquote conventional wastewater treatment is somehow bad or can't be designed well. And I'd like to challenge that notion a little bit, because I think we're getting better at treating wastewater in ways that have complementary benefits to them. And even this example here is one of my favorites. That's the Brightwater treatment facility outside of Seattle, Washington, and that's one of the world's largest membrane bioreactors. So it's a very large, or very efficient type of treatment system, pretty large scale. And that whole site was designed by Methuen, who are architects, and they designed a wastewater treatment facility and a visitor education center. And so I think that that's a really powerful opportunity for them. They're bringing people into that campus, and they're showing them and sharing with them, how wastewater treatment works and what that looks like. So it's possible to design these systems with the idea of creating community benefit and restoration opportunities, right? So we know we can treat wastewater well. We know we can create community benefit. Those are all things that are real and possible. And so we don't have to accept like the alternative to that, which is like, something ugly or funky or that's underperforming. It's that we're past that as a society and as engineers and designers. And also there's this other opportunity, which is kind of the heart of today's talk, about innovating with ecology. Is showing some systems that were created by Dr. John Todd, who is a biologist and one of the innovators of early ecological design. I'd say he was a pioneer in the field. He's not the only one, but a pioneer in the field of ecological engineering and taking these ideas from natural systems and natural ecologies and applying them into a wastewater treatment setting, or a setting of like in the image here on the screen on the bottom left is a landfill leachate system of cleaning, water that was polluted from a landfill leachate using algae and solar aquatics. So I spent the first couple of years of my career working with Dr. Todd and helping to design these systems here on the screen, which were then taking that idea and applying them to open systems or more open systems to basically expand the concept of where and like the places where and the ways that we can treat wastewater. And so this canal on the top here is in China. It's a combined sewer wastewater canal right through an urban area, and we transformed it into a wastewater treatment plant by floating a series of wetlands and installing aeration. And similarly, we retrofitted a lagoon, a food processing lagoon in Maryland on the bottom left with floating ecosystems and aeration to kind of inject that ecology piece into the system. So natural treatment systems or ecologically designed treatment systems can be configured for a diversity of applications at many different scales and in a range of climates. Like nature, they are adaptable and continue to evolve. So in treatment wetlands, which are one type of technology that would fall into that basket of natural treatment systems, we do know a bit of what's happening. And generally speaking, what we're trying to do is be good gardeners of a diverse range of microorganisms. And so the treatment that we're seeing is a result of biofilm growth, bacteria colonies and microorganisms that are growing on the surfaces of the gravel and on the roots of the plants, and that are taking that waste equals food thing to heart and transforming the waste that's in the water into food for their own processes, which then the plants are benefiting from, et cetera. There's also some filtration that is happening, stabilization of certain types of chemical compounds, and a mass proliferation of billions of microorganisms that are coming together to kind of adapt to the waste stream over time, which is one of the most amazing things about it, is these systems can evolve. And that's partly what we designed them to do, is to be able to adapt to the waste stream. And then in the case of constructed wetlands in particular, they provide a lot of other benefits. Beyond cleaning water, they provide habitat, biodiversity, carbon fixation and storage. They can denitrify by removing nitrate from water and turn it into a gas. And so there's a lot of other benefits for putting in some of these systems besides just creating clean water. So there's some design considerations that I wanted to talk about today. And one of them is the question of like, is a natural treatment system applicable to a project or a site or a facility that I'm working with or might contemplate? And so a few outline about where these systems can really be useful is for new developments where you don't have wastewater treatment, retrofits, upgrades, or polishing of failed systems or those that have new treatment goals or elevated treatment goals, projects that are beyond the reach of a sewer and that you don't want to run a sewer out there because that can have some negative consequences. Water reuse and demonstration sites, even those that might be inside the sewer grid, but you can use these systems to recycle water and still use the sewer as the ultimate discharge point for what you don't reuse. Developing world situations, many of these systems can be designed with almost no moving parts or very minimal energy requirements. They can be pretty robust to improve water quality in places where you don't have access to some of the more developed technologies. And then in places where you want to leverage a habitat or community benefit for, something beyond just the wastewater treatment piece. And so we have, among other groups and firms over the many years, developed natural treatment systems for a wide variety of settings, including places like institutions and centers, residential and mixed-use communities, campuses, schools are very popular, visitor and nature centers, municipal systems, and then light industrial and food processing as well. And so if you want to ask yourself, what is a good candidate? What makes a project a good candidate for a natural treatment system? There's a few things we've learned over the years in that, one of the first ones is you have to have some sufficient space available and access to natural sunlight, because most of these systems are solar driven, at least from, part of the plant where the plants are growing. We want to have some space available. The more space you have, the better, because you can rely more on the passive treatment. The less space you have, we're going to invest more energy to shrink that footprint. So there is a balance there. You will want to have a need or a want to treat wastewater. So I say that because sometimes with people who just want to treat wastewater, they don't have to, but they want to, because they want to demonstrate this technology and this approach. And sometimes they're going beyond what's required by the permit, right? You might be able to put in a septic system, but people want to often add a treatment wetland because they want to improve the environment and the water quality, and they want to demonstrate. If you desire more benefits from your wastewater treatment investment, a lot of wastewater treatment systems are sort of put away and you don't think about it, and people want to bring that water back into the landscape and the environment. You want to reduce your energy, your sludge, and your capital cost. A lot of these systems are pretty low energy. You want to improve your water quality so that you can reduce your discharge cost or your drain field cost. You have a vision or a mission for your organization or your project that's aligned, and you want to demonstrate your stewardship. Some of those folks are also pursuing things like the Living Building Challenge, have biophilic design goals or green building aspirations. But importantly, to remember, you also have to have a tolerance for maintenance and operations for a wastewater treatment system, which many people don't have experience with that in general. So you have to have, the ability to bring somebody on board to operate a low wastewater treatment system, and also a garden, basically. It's like putting those two together. So there's a spectrum of natural treatment systems, and they can range from very passive with no moving parts to much more active and pretty complex systems, particularly for getting into water recycling or very small footprint systems. And they too, like conventional wastewater treatment, have a range of water quality, operational complexity, carbon footprint, and cost. It's the same thing. It's just, they can be configured along that spectrum. Wastewater treatment systems also have a couple attributes of how they're typically configured. And one of them is a treatment train approach. And so we typically want to stack together a few different kinds of systems, a few different kinds of ecologies to be able to provide redundancy and resiliency. Similarly, providing recirculation, equalization, and purposeful nutrient cycling helps us reach those higher level performance goals. Some typical stages of wastewater treatment in general, but that also apply to natural systems, are primary treatment, secondary treatment, and tertiary treatment. And if we're in a situation where we're discharging or reusing that water, we're going to disinfect and filter it as well. These systems can have a very high level of performance if they're designed to do so. This is an example from the Stroud Water Research Center, where we are hitting tertiary standards, BOD and TSS of less than 10, total nitrogen of less than 10, or in this case, we're actually hitting less than 5. And so we're able to meet those goals and also buffer against the significant variability that's just the nature of wastewater. It's very peaky in how it comes in terms of its flows often and the strengths. And so the red lines on these graphs are influence strengths for BOD on the left and nitrogen on the right. And that are basically the green levels are the effluent. So we're basically flattening those curves, if you will. I'm going to just wrap up with a few quick project precedents just to show you how these systems can be integrated. We've highlighted a few other of these types of systems in past webinars. You can go check those out. I picked a different suite of them to go through today. But this one, for example, at the Desert Living Center in Las Vegas, Nevada, is a treatment wetland system where the wetlands themselves were designed to mimic the original natural spring-fed features that would have existed in this spot, while also providing clean water and becoming a landscape amenity. People get their wedding pictures taken there. The Stroudwater Research Center, whose data I showed you, this treatment system, part of it is located right at the entrance of the building. So everybody's coming in and out. There's a bench built around it. This is a beautiful design by Andrew Pogon, landscape architects that worked with us on this. And that system is located to invite curiosity, observation, reflection, and put it right in the front. The OmniLife Stadium in Guadalajara, Mexico, is an example of treating wastewater where there isn't really adequate sewer infrastructure and putting it to full reuse for toilet flushing and wash down, and then creating a kind of striking part of the landscape. And then this is an older project, but that I wanted to highlight because they've just finished the second phase of their treatment wetlands. But this is down outside of Atlanta at Serenbe, which is a new urbanist community outside of the city. And they built their wastewater treatment system probably 15 years ago now or so as a community amenity, as part of the development, that is also processing all of the wastewater, about 30,000 gallons a day, and becomes part of the landscape. And then they just now went on and finished phase 2 this last year. And so what does the future hold? There's a few things that we think are evolving, and there's a little bit more of an experimental phase, but one of those is reducing the idea of wastewater at all to the concept of nutrient recovery, right? So back to that waste equals food. And one of the ways to do that is with composting toilets, and the idea of using them to recover products for building soils. And then similarly, and even a little bit more out on the edge, is recovering nutrients from urine to make fertilizer. And there are products on the market right now for urine diverting toilets and urinals, and then batch processing, small processing systems to basically make phosphate and nitrogen fertilizer products from what would otherwise be considered, a waste that we have to treat in a wastewater treatment plant. The handout that's available to everybody attending the webinar includes these books and links here, but these are a few of our favorite and most useful resources. The classic book, Natural Wastewater Treatment Systems, on the upper left there, has a wide range of systems in it, and then a few of these are other treatment wetland recommendations, and Dr. Todd's newest book, and then a few other links for different societies and conferences that are doing a lot of the science behind these systems. So thank you very much.
Awesome. Thanks, Erin. So I'll turn my camera back on. And Erin, turn your camera on. We can't see you.
I was a little concerned of blowing something up again, but I will do it.
Gotcha. Okay. Excellent. Okay. So I will say, so Erin and I have worked together for I think about 10 years, and I never knew you have a favorite wastewater treatment plant before. So that was nice, interesting little factoid to learn. Okay, so first question for Serenbe, what type of wastewater is treated in the area that you showed?
Yeah, so Serenbe treats all of the wastewater from that community, and that community has, it's primarily residential, but it has some restaurants, actually some pretty significant restaurants, and like small shops and things. So it's primarily a residential strength effluent, but because of Serenbe itself is built by restaurateurs, Steve Nygren, they have a really nice restaurant scene going on out there. So the wastewater is a little higher strength than it would be if it was just houses. It's an amazing place to visit if you're in Atlanta, by the way.
Sounds like it. Cool. Next question is, at what scale do you think natural treatment systems make sense?
So I think they make sense at a variety of scales. Where I think they are hardest to justify is like the single household or very, very small scales, because you want to have a consistent food source for them. And if people go away on vacation for a few weeks or whatever, you risk kind of dropping off the flow of nutrients and water. And so sometimes that can be challenging. I think there's a lot of potential also in very, very large scale natural treatment systems that might look a little different than some of what I showed today, but that are being used to buffer the discharge from, like, even our existing municipal wastewater treatment systems right now. Most of those discharge either directly to the ocean if you're on a coast, or more frequently directly to a river if you're inland. And although wastewater treatment technology has evolved and continues to evolve, there are still contaminants of concern. There are still temperature issues on the back end of a lot of those municipal treatment plants. And so where space allows, putting in, these kind of larger filtration wetlands as polishing or buffer opportunities that also are creating, habitat and providing a little bit more cleaning, I think make a lot of sense. It's land limited. You have to have the space to be able to do that.
Got it. Okay, so starting to get a bunch of questions rolling in. Okay, so along the space, here's a question in its most compact form. How much land is necessary to process, say, a 100-home community?
Okay, I have a calculator. So it depends on a lot of things. And one of the main questions is, like, well, what are we going to do with the water? And so if you have a very, high level of water quality you need to hit, you're going to have more space and more complexity. If your water quality discharge requirements are a little less, then you have a smaller footprint. But generally speaking, we want to exceed the water quality requirements of whatever the permit is, and use these systems as ways to better protect groundwater and better protect surface water. And so most of these systems that you're seeing here are discharging to groundwater, which generally has one more step. It has that filter of the earth, like the genius of the meadow or the forest floor, is that we're able to get some filtration through that. So just assuming that we're going to take those 100 households and discharge them to like a drip irrigation system or a drain field, I would say that's maybe 10,000 gallons a day. No, it's going to be more than that. 10 to 20,000 gallons a day, depending on how big of houses these are. And so a treatment wetlands, a very rough rule of thumb for treatment wetlands would be 2 gallons per day per square foot. So you'd need 10,000 square feet for a wetland for that. An eco machine, which I showed, would be a fraction of that size, maybe 2,000 or 3,000 square feet. So there's a range there.
Okay, so a few more, some really good questions. So to kind of follow up on the question of scale, what about seasonality? Would a seasonal facility be a challenge, and how would it be maintained if there's no effluent for an extended period of time?
Oh, that kind of seasonality. Yeah. So that's a problem for any kind of wastewater treatment. No matter what you're doing, there's some level of impact of a seasonal site or a facility like that. And if you're looking at just basic septic systems, those are probably the least impacted by seasonality. But the bad news is that those are the ones that are usually the biggest polluters of groundwater when you are operating. And so having a balance between, a system that provides good water quality and can still be shut down is your goal. So treatment wetlands themselves are actually pretty robust because they have a lot of work happening within the system. You just have to make sure they don't either freeze or dry out. And so those are the two challenges with those. Eco machines or systems that are in like a greenhouse, those have a little bit higher food requirement. And so sometimes you can actually like feed those. And right now with COVID, we are working with a number of our operators to address just this very question, because many places, all their wastewater is gone, and so we're just working with them to make sure that they're maintaining the very basic level of management and kind of dialing everything back down to keep the biology alive, and keep the systems functioning. But, they're just going to have to, what you do is called a biological ramp up when you know that you're going to have people coming back as you start to ramp up the system and maybe even feed it a little bit.
Okay. Okay, next question. Can you talk about regulatory hurdles that you faced using these systems and how to work through them?
Sure. Yeah, there are some. So that the regulatory hurdles question varies significantly state by state and country by country. And some states are on top of this, and they have codes or guidelines written that accommodate treatment wetlands, or more commonly treatment wetlands. Eco machines and some of those other ones might be a little less common, like the floating restorers. So there's probably more of some upfront work there. But so in states where you have treatment wetland regulations, it's generally speaking relatively straightforward to permit these systems because you're able to kind of follow their guidance. In many states where that doesn't exist, then we provide some of those resources that I shared on the previous screen. We help regulatory agencies look at, what's the science behind this, what's the engineering behind this, and as licensed engineers, we can show the data and the professional opinion and experience show that we're able to achieve the water quality goals that they would need, with another system. Where we have found it hardest to implement is where the regulations are very prescriptive or require like a certain type of certification. Because these systems are custom designed and they're open and they're a little more natural, they don't have like an NSF certification or something that says it does this thing all the time, So that's where it's a little bit harder. But we've not found too many situations where we haven't been able to at least get an experimental permit. And we actually are okay with those because then you're getting some data collected and we're, able to kind of make the case and show the outcome from a system like that to make it a little easier for others or to at least, prove the case.
Great, thanks. What about the ability of these systems to treat trace constituents or pharmaceuticals or other pollutants?
Right, good question. So there is evidence that is possible with these systems. Has there been enough scientific study and fully developed research programs work around that? No, not yet. And so there's a handful of studies, including one that was done at the Omega Institute, where they were measuring that. And that system has an eco machine greenhouse with a lagoon, a constructed wetland, and a sand filter. So it's pretty really robust system. And it was removing some pharmaceuticals and some other hormones, I think, that they were testing for. But I think that's an area of additional needed research and funding, honestly. But the anecdotal evidence is good. And it's not a surprise, I think, to most of us who work with these systems, because one thing I didn't really point out here is that a lot of these treatment systems, and particularly the wetlands, a water drop that enters on day one doesn't come out the other side until like 4 days later, maybe even longer. And so there's a lot of time for different transformational processes to happen. And there's a lot of different ecologies that organisms, different ecologies and different organisms. So we're in anaerobic conditions, we're in anoxic conditions, we're in fully aerobic conditions sometimes. And then sometimes you rinse and repeat. And so you're getting a wide variety of opportunities to remove and breaking down basically those compounds. A lot of conventional wastewater treatment systems, that time period is more like 8, 10, 12 hours. It's much shorter. And the diversity of the barrage of things you go through is a little less diverse. However, membrane treatment systems are very good at removing those constituents because they're using a membrane at the back end to kind of make sure none of that stuff comes out the other side. So there's different ways to get to a similar outcome.
Great, thanks. Have a couple of questions related to specific applications. So one is near and dear to my heart, being from Cleveland, but can this be used to treat agricultural runoff along Lake Erie, for example, which I believe we have talked about on and off over the last few years? given the flat landscape and.
Yes. Yeah. And in fact, I just circulated a chapter of a book that was just released this week. The chapter is called Constructed Wetlands for Managing Agricultural Runoff, which is embedded in a larger book around agricultural contaminants and types of runoff that you would see from both the fertilizer and the pesticide and herbicides. And so there is work being done using treatment wetlands to manage that runoff. Now, when you're in a non-point source pollution situation like that, where you have all sorts of diverse hydrological things happening. So you've got surface runoff, you've got shallow groundwater, you've got maybe deeper groundwater, you might have under drains. A lot of these ag fields are drained, right? Part of the challenge in general is just knowing where and how to intercept that water and get it into the treatment system. And so there's been all sorts of different work done of trying to like install mini wetlands in trenches and, to put them in areas where we think we can, gather that water. And so that's part of the challenge. But wetlands, generally speaking, are anoxic and anaerobic, and they're very good at taking nitrate and denitrifying that. So from an agricultural perspective, they're a really good fit. It's just getting the water to the right place.
Got it. And then we also had a question about using the constructed wetlands to treat contaminants and stormwater runoff at concentrated animal feeding operations.
Yep. It's another area where there's been a lot of very early research actually was done with a combination of both a pond ecology and treatment wetlands. Because if you were to run a CAFO, so like a confined feeding operation effluent directly into a wetland, you could actually burn it. It's a little too hot of a waste stream. And so a lot of the work has been done around using the pond ecology to settle and digest that waste and then put it to treatment wetlands. But even still, that wastewater is very, very challenging, and for good reason, because you're basically concentrating, a massive amount of food waste source in one location. And generally speaking, as a firm, we have shied away from that work because of the other auxiliary concerns around animal treatment and the way that kind of food operation operates. Doesn't mean that's a problem it still needs to be solved. But wetlands can be part of a solution, but it's proven challenging.
Got it. Okay, let's move on to maintenance. Question here: what sort of long-term maintenance have you observed with some of the older systems? For instance, replanting, cleaning of filter material, and other items like that.
Yeah, those two right there. So we have a lot of treatment wetlands that we visited that are 10, 20, 30 years old. And the two things that we see are that the plants tend to do some interesting things with evolution. And if you don't maintain them like a garden, they tend to diversify themselves with whatever the most aggressive local plant is. And so in some places we have had weeds come in. In some places we've had some woody species like small trees. And so to stop that part from happening, it's good to maintain them like a garden where you're, keeping up on weeds and particularly trees. You don't want trees in there because these systems all have liners. You don't want the roots to get in. And then we've seen the media over time. Wetlands are wanting, like in nature, they try to evolve towards a meadow and then towards a forest. That's partly what we're seeing. So we see meadow grasses and trees because that is a natural progression. So part of what we have to do is maintain the treatment media itself too, because it tends to grow. It makes beautiful soil. So we usually see that after a period of time, 20 years, something like that. Sometimes you have to clean the front end of the gravel out a little bit, or let it dry out, kind of fill it back up, and try to flush that out. And then here in the Southwest, and in places where you get a good amount of UV exposure, if the liners on wetlands are not maintained and covered, then those can break down in the sun over a long period of time. But we went out this week to a wetland that's 30 years old and it's working fine. So.
Erin and Jen, we have time for about one more question.
Okay, last question, Erin, is what's a great example of a large municipal scale natural treatment system in the United States?
There are a handful of them. The first is up in Arcata, which I still think is one of my favorites. It's just like an interesting experimental system that's discharging or that's filtering water from the discharge of a municipal system. And then the one that's in the middle upper part of this page here is a project I talked about a few weeks ago at a Watering Hole Wednesday. That is the Fern Hill treatment system outside of Portland, Oregon, which is discharging, let's see, it's receiving about, I think, 4 to 10 million gallons a day, depending on the weather, of treated effluent from the municipality. But it's 90 acres of constructed wetland or natural treatment wetland that's cooling the water, removing additional nutrients and metals, and also serving as a bird habitat. So that's Fern Hill with Clean Water Services is the utility that built that.
Thank you so much, Erin, and thank you, Jen.